Okay, so we're looking at formulas of sequences today. We looked a little bit at them yesterday when we were finding the terms, but today we're going to write the formulas when we're given part of the sequence. So we said yesterday that an arithmetic sequence follows a linear pattern. So remember, linear is like y equals mx plus b. So we don't have x's and y's, we have n's and a sub n's, but it's still going to have that same general look about it. And then a geometric sequence follows an exponential pattern. So remember, exponential looks like y equals a times b to the x. So we're going to look at two different formulas today. The first one is the explicit formula. So the explicit formula is the formula that we saw yesterday, where we plugged in 1, 2, 3, and 4, and we found the terms. So it is used to find any term in the sequence. Okay. So if you want to find the first term, you plug in 1. If you want to find the 100th term, you plug in 100. So you can find any term in the sequence if you know the explicit formula. So you still have to decide first if it's arithmetic or geometric. So if it's arithmetic, then the formula is a sub n equals a1 plus d times n minus 1. If it's geometric, it's still an equals a1, but remember this one we're multiplying, so it's times r to the n minus 1. Okay, so what makes it exponential is the variable being in the exponent. So n minus 1 is your exponent. Okay. So we said yesterday a1 is the first term. And n is the number of the term. So if you're looking at, for the fourth term, you plug in 4. So it's the number of the term that you're trying to find. And then D is the common difference. So remember, that's what you're adding or subtracting each time. And that's for your arithmetic. And then R is your common ratio. And that's what you're multiplying by each time. Remember, if it's dividing, you make it multiplying a fraction. Here. Let's do one. So let's write the explicit formula. For each. So let's say first we have the sequence 3, 8, 13, 18, etc. So to write the explicit formula, first we have to decide, is it arithmetic or geometric? So what's happening with this one? Adding 5. So is it arithmetic or geometric? Arithmetic. So we're looking at this one. So we just want to write the formula. We're not trying to find a specific term. So an and n are going to stay our variables. So we have to plug in for a1 and d. So what is a1? What is the first term? 3. And then we said each time we're adding 5. So that is our common difference. That's d. So then we just plug those two things in. So an equals, our a1 is 3, plus, our common difference is 5, times n minus 1. Can I simplify this? Yeah, what can I do? Yeah, I can distribute this 5. So then we get an equals 3 plus 5n minus 5. And then what's my last step? Yeah, I can combine like terms. So 5n and then 3 minus 5 gives me negative 4. So then with this formula, I can find whatever term I wanted to find. So if you want to check yourself, if I look at this, my first term is 3, my second term is 8, my third term is 13, my fourth term is 18. So let's say we wanted to check it and see if we really do get 18 for the fourth term. So if I plug in 5 times 4 minus 2, I get 18. So that's one way you can check yourself if you want to, is just plug in 3 or 4 and see if you get the third term or the fourth term. Questions? Let's do another one. So this is the first term, so you plug in 1. Second term, you plug in 2. Third term, you plug in 3. Fourth term, you plug in 4. Yeah. So n is the number of the term. So let's say we have this 4, 8, 16, 32, etc. Good. So we're multiplying by 2 each time. So is it arithmetic or geometric? Geometric. Good. So again, we're just wanting to write the formula. We're not finding a specific term. So we still leave an and n as our variables. So we need a1. What's our a1? 4. And then our common ratio is 2. So that's what's happening each time. So then we plug it in. So an equals a1, which is 4, times our r, which is 2, to the n minus 1. Can I do 4 times 2 and get 8? No, you cannot. Because remember what we talked about yesterday, you have to do the exponent first. We don't know the exponent, so we can't do that, so we just leave it. So if it's geometric, you plug in a1, you plug in r, and you're done. You don't have anything to simplify. But again, if we wanted to check it, we could say our fourth term is 32. So we plug it in, 4 times 2 to the 4 minus 1, we get 32. Questions? Okay. So then the other formula that we're going to look at is called the recursive formula. So with the explicit formula, you can find any term. All you have to do is plug in the number of the term. But for recursive formula, you can't find any term. You can only find the next term. So recursive formula is used to find the next term. So if you have the first term, you can use it to find the second term. If you have the second term, you use it to find the third term, etc. So again, you still have to figure out if it's arithmetic or geometric. So if it's arithmetic, it looks like this. A sub n equals a sub n minus 1 plus d, and a1 equals a number. So it tells you what the first term is. Okay. If it's geometric, it's the exact same thing, except instead of plus d, it's times r. That's the only difference. So a sub n equals a sub n minus 1 times r, and a1 equals a number. So the difference here is with the explicit formula, to find the first 3 terms, we plug in 1, 2, and 3. With the recursive formula, you're not plugging in 1, 2, and 3, you're plugging in what the term actually is. Okay, so let's do a couple like that. So we want to find the first 3 terms. So let's say it gives me a sub n equals a sub n minus 1 plus 8, and a1 equals negative 12. So it already tells me my first term. So I just need to find the second term and the third term. So the nice thing about these is it tells me what is happening. So it says an equals an minus 1 plus d. Well, in this one it's plus 8. So that right there is our common difference. So all we have to do is start with the negative 12 and add 8 each time. So negative 12 plus 8 is negative 4. Negative 4 plus 8 is 4. Okay. But you're probably thinking, well, what does all that other stuff mean? So if we wanted to find the second term, 2 would be our n. So that would look like a sub 2 equals a sub 2 minus 1 plus 8. Okay. So if we wanted the second term, we would plug in 2. Well, what's 2 minus 1? 1. So a sub 2 equals a sub 1 plus 8. What does a sub 1 equal? It told me. Negative 12. So if I plug in negative 12 plus 8, I get negative 4. Okay, so that's how the formula works. That's why it looks the way that it does. And you can do this every time, but there's really no need because it tells you what's happening, so you can just add 8 each time, like what we were doing yesterday. Questions on that? Alright, let's do another. So let's say we have a sub n equals negative 2 a sub n minus 1. So if it's geometric, it can have the r out front, like this one does, or it can have it in the back and say times negative 2. Either way, it doesn't matter, it's the same thing. And so we need to know a1 is negative 3. So again, it gives me a1. So I need a2 and a3. So what is happening each time? What operation is between the negative 2 and this a? Yeah, multiplication. So we're just multiplying by negative 2. So that negative 2 is our r. So we just multiply. So negative 3 times negative 2, 6. And 6 times negative 2, negative 12. And that's it. Now, sometimes it will have both arithmetic and geometric properties. So let's do one of those and then we'll move on. So let's say we have an equals 4, an minus 1 plus 3. And it tells me a1 equals 5. So if I have this times 4 and plus 3, which of those things do I do first? Do I add 3 or do I multiply by 4 first? Yeah, multiply. So think order of operations, please excuse my dear Aunt Sally, multiply or divide first. So we do 4 times 5, which is 20, and 20 plus 3 is 23. So then for the third term, we do the same thing. We do 4 times 23 plus 3, good, which gives me 95. So explicit formula, you're plugging in the number of the term, 1, 2, 3, 4, 5, 6, 7. Recursive formula, you're plugging in the previous term. Questions? For whatever reason, recursive formula seems to trip people up, but it's really as easy as that. So let's write a couple, then we'll be done. So write the recursive formula for each. So we've got 7, 14, 21, 28, etc. Okay, so when we're writing the recursive formula, every single time you can write an equals an minus 1, a1 equals. So for every single one, no matter what is happening, this is what it looks like. An equals an minus 1, a1 equals something. And then you just fill in what's happening. So what's happening each time? We're adding 7. So an minus 1 plus 7. And then where do we start? What's our first term? That's it. So an equals an minus 1. What's happening? A1 equals what? That's all. You don't have to simplify it, nothing. That's all you got to do. One more. Let's say we got 64, 16, 4, 1, etc. So what's happening each time on this? So it's dividing by 4, which is the same thing as multiplying by 1/4. Very good. So again, an equals an minus 1. What's happening? Well, we're multiplying by 1/4. And my a1 equals what? Good, 64. That's it. So the first three things, an equals an minus 1, a1 equals, those are always the same. And then you just say, what's happening? Where we start. So if it's dividing, like this one was dividing by 4, you want to make it into multiplying. So dividing is the same thing as multiplying by the reciprocal. So if it's 4 over 1, if you flip it, it's 1 over 4. The other way you can get it is you can do the second term. So 16 divided by the first term and make it a fraction. Either way you get 1/4. Questions?